Hey everyone, I'm Jenny. In this series of videos, we're going to do a Q&A on streaming data. The leaders of Estuary have been hard at work attending many podcasts around the data engineering community, sharing their valuable knowledge. You may not have caught all of the podcasts, so we're going to do a YouTube series taking the best out of these podcasts and presenting the knowledge to you in a Q&A format. If you have any questions about streaming, feel free to leave a comment and we'll try to get to it in future videos in this series. In this video, we're going to have Phil, our VP of Engineering, go over how is idempotency implemented in streaming systems. Let's get right into it.
Yeah, that's a great one because I think at a high level, I would say that exactly once transactions are essentially, it's a hard and fast requirement for streaming.
Yeah.
If you're talking about a batch system, if you're doing the very kind of the naive batch job of copying all of the data from the source to the destination, there's some interesting nuance there and a number of different approaches that people take when it comes to just deciding how do you make that idempotent. And again, trade-offs abound. Even considering just the happy path for a batch job, right? We're thinking, okay, every day we're going to have a batch job that runs and it's going to copy over all the data from the source to the destination. The first most obvious thing we have to deal with is this users table or in your destination. After that first run, it already has data.
Yeah.
So what are you doing with it? And there's a couple of common approaches for dealing with this. One might just be that you just truncate and recreate the table every time. And that's honestly not terrible for a lot of people. It has some downsides, probably the biggest one being that, especially if it's a big table and it can take time to drop and recreate, then your consumers of that data have downtime. And again, with a trivial example of one source and one destination table, maybe that's fine.
Yeah.
But if we're talking about 500 destination tables that are all going down getting truncated and recreated at various times throughout the day, that quickly becomes untenable for an analyst, right? They're not able to make use of that data because it's easily becoming inconsistent.
Yeah.
So what do? You might do things like make your batch job incremental. So you select only the updated rows, and now you're just, inserting or updating your destination. That's great. That works until it doesn't. When your source table has just a completely different schema, you still have to recreate it there. You can also just create a new users table every time and suffix it with maybe a date or an identifier of which batch run it came from.
Yeah.
Again, it works, but the downside there is that you really are pushing some complexity onto the consumers of that data. They now have to know which one was the latest successful batch run. Which table should I be reading from? Again, there's answers to that. They're not unsolvable problems, but it is complexity that you have to deal with. In the batch world, failures also, it really depends, I think is the answer. When you talk about idempotency, which strategy are you using there? One possibility might be to say, you're going to add the data to the destination and give it a new table. And if all the batch runs are successful, maybe I have a view that's just called latest users. And I update that view to point to my new table or something like that. So there's answers for that. I think a big part of what I see as a problem here is partial failures of batch jobs. It can be really difficult to identify when you have a job that is working with incomplete data. And so I know we keep coming back to these kind of failure scenarios and idempotency, but I think it's really important because to me, the worst possible failure mode here is that you're going to deliver data that is incorrect. With streaming systems, we tend to approach that a little bit differently. So with a streaming system, again, these are long-lived things. And so it forces you to deal with that problem right up front, right? You can't say, I have a streaming task and it's just going to run continuously and it's never going to go down, right? It's not realistic.
Yeah.
There's no way you're going to have 100% uptime on any process.
Yeah.
So the strategies are a little different, but it forces you to deal with that in your streaming platform. And at a high level, that's really the answer, is your streaming platform has to be able to deal with that. And your strategies are, you've got transactions, which I think are absolutely the way to go here. And then you've just got other platform facilities for monitoring, restarting, things like that. As with any process, there is such a thing as an unrecoverable failure in a streaming task.
Yeah.
And so I think that's a big one. So what happens if going back to a transform example, right? I've realized that there's a bug in my transform code. Now I've read maybe 90% of the data and there's a bug in my transform code. I've produced 90% of my outputs. What do you do? And I think the answer to that, again, comes back to you've got to have consistency in your platform for how you deal with these things.
Yeah.
For us, the answer is you create a new collection, right? So you get rid of your old task, you stop it. You're going to say, okay, I'm going to have a new transform that comes in and it's going to start from the beginning. When derivation has a failure, then we need to be able to restart it. If there's a bug in that code, we need to create a new derivation. Here again, that's where I don't really have a better answer other than your platform has to give you an answer for how to do this. And you got to make it pretty easy on yourself, right? I've been coding for a solid 10 years now, and I don't think I've ever written a program without a bug. I'm sorry. It's very difficult to do. And so iteration is part of the process.
Yeah.
You've got to do it. You've got to make it easy and have things start to backfill using that historical data. So that means you're retaining that historical data for whatever period is significant to you. That way you can start over from the beginning. Your platform has exactly once transactions. This is important because for all of the other failures, right? So if it's a bug in my code, I've produced bad data or something like that, there's just nothing much else to be done other than starting it over. There's lots of other reasons why something might fail, right? And for those, I think the transactions is really the way to go. Some people might be thinking, why don't you use idempotency instead? And certainly technically on some level, that's always kind of part of the process. But I do want to address the idea of saying, some people might be tempted to say, I'm going to add an idempotency key to every document, and I'm just going to have every consumer check that and see if they've processed it before. And if not, then process it again. And I think the risk here is really that you're forcing that complexity into all of your consumers. And the risk is when you get that wrong, it can be really bad.
Yeah.
Right. You're getting bad data that's leaking to basically everything downstream. And that can be pretty tough. You're introducing additional state that everything has to work with. If you still think, yeah, but we could do it right, consider problems like where you have a derivation that is reading from multiple sources, right? Idempotent processing of that source data becomes a much more complex question when you consider that you're reading from multiple sources. Now, what happens if you process something in a different order, which is something that, can happen, right? Like ordering in any kind of distributed system is extremely complex. Yeah. I think, not to beat a dead horse, but that transactions are really important for this to all work. You really don't want to process a streaming event more than once. You will absolutely get bad data if you do.
Yeah.